Welcome to Học tiếng Anh với Joseph, where we build vocabulary and practice pronunciation through reading. Continuing with The Cat in the Box, the story today concerns the flowering of evolution theory. And of course, when we talk about evolution theory, we have to talk about Charles Darwin. Charles Darwin developed his theory of natural selection from observations of the living world. But he also carried out experiments to test that theory. Some of the most important of these were detailed in his book on the various contrivances by which British and foreign orchids are fertilized by insects and on the good effects of intercrossing, usually known simply as fertilization of orchids, published in 1862, 3 years after the publication of On the Origin of Species. Fertilization of orchids provided the first detailed explanation of how natural selection affected the co-evolution of orchids and insects. Although it did not sell to the general public in the same numbers as The Origin, it became a classic among biologists and has influenced their thinking all the way to the present day. Darwin's work involved observations, dissection of plants to examine their inner workings, and experiments in which plants were fertilized by hand, with pollen being transferred from one flower to another. His superbly accurate dissections revealed previously unknown features of these plants, including the discovery that members of the genus Catasetum, which had very different flowers and had been thought to be entirely separate species, are actually male and female forms of the same plant. In the 1850s, Darwin gathered evidence to confirm the idea that plants are fertilized by insects transferring pollen from one flower to another as they feed, so the plants do not fertilize themselves. This is an important element of the theory of natural selection because such cross-pollination provides the variety on which evolution acts. The offspring inherit some characteristics from each parent, giving the potential for them to be slightly different from their parents. Advantageous differences spread and become common. Damaging differences die out. Although he seldom saw insects in action pollinating the orchids near his home in Kent, Darwin was able, by examining the flowers at regular intervals, to discover when pollen had been removed, confirming that they had been visited by insects. In The Origin, he introduced the idea of co-evolution, whereby insects and plants become adapted to each other as the generations pass, and wrote, quote, "A flower and a bee may slowly become, either simultaneously or one after another, modified and adapted in the most perfect manner to each other, by the continued preservation of individuals presenting mutual and slightly favorable deviations of structure," unquote. Insects evolve to be better able to extract nectar from the flowers, and the flowers evolve to be more efficient at sticking pollen to the insects as they feed. Darwin obtained different orchids from correspondents around the British Isles and beyond. This led to a dramatic discovery and a testable scientific prediction. When an insect lands on the large projecting lower petal of an orchid, it pushes its head and tongue, proboscis, down into the center of the flower to get to the nectar, giving the plant the opportunity to stick pollen message to the insect. The proboscis is coiled up except when the insect is feeding, but flicks out when needed. If it is too easy for the insect to reach the nectar, the pollen never gets stuck to it. But if it is too difficult, the insect will not come to feed. So plants evolve to make it difficult but not impossible for the proboscis to reach the nectar. Variation means that in each generation, plants for which this is impossible do not survive, and plants for which it is too easy to not produce as many offsprings as plants for which it is just right. At the same time, insects with longer tongues will do better at getting nectar and will thrive, leaving more offspring. As tongues get longer, evolution of the flowers favors less accessible nectar. As nectar gets less accessible, evolution of the insects favors longer tongues. So there is a kind of arms race. Plants gradually evolve less accessible nectar, and insects gradually evolve longer tongues. Coevolution. In the end, one kind of plant and one kind of insect become so well adapted to each other that neither can survive on its own. The insect feeds only on one species of plant, and the plant is fertilized only by that species of insect. Darwin's experiments and dissections showed that the nectar of the Star of Bethlehem, an orchid from Madagascar, could be reached only down a tube with an astonishing length of 11.5 inches or 29 centimeters, 290 millimeters. When he first examined samples of the flower, he wrote to a friend with the news, exclaiming, "Good heavens! What insect can suck it?" It implied the need for an as yet unknown morph with a proboscis of 10 to 11 inches long to pollinate these flowers. He wrote in Fertilization of Orchids, "There has been a race in gaining length between the nectary of the Anthracium and the proboscis of certain moths. The insect, a variety of hawk moth, was found in 1903, 21 years after Darwin died. It was named Xanthopan morgani predicta because it has been predicted by Darwin." Look at this. This is the tongue. Cái lưỡi của nó này. Wow. To the vocabulary section, theory of natural selection, fertilization, fertilize, fertilizing, fertilization, coevolution of orchids and insects, coevolution of orchids and insects, superb, superbly, advantageous differences, damaging differences, proboscis, kind of arms race, hawk moth. Hawk moth. Hawk moth. Well, thank you for your time. And as always, I will see you in the next story until story number 100 on this series. Bye for now.